Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Yusuf Wazin, and I will present the four basic forces. The first one is gravitational force. It exists between any two objects with masses. It's always attractive and its range is almost infinite. Its magnitude obeys the inverse square law and is the weakest of the four basic forces. Its relative strength is 10 to the power of negative 38. Very weak. The next one is electromagnetic force. It exists between two charges and binds electron to the positive charge nucleus to form an atom. Its range is almost infinite, and it also binds atoms together to form solids, liquids, and gases. It is attractive for unlike charges, but repulsive for like charges. Its magnitude obeys the inverse square law. The relative strength is 10 to the power of negative 2. The next one is the strong nuclear force. It's only on quarks and binds three quarks together to form a nucleon. It acts on nucleon so that they group together to form a nucleus, and its range is 10 to the power of negative 15, and it is the strongest force. The relative strength is 1, very strong. The next one is the weak force. It acts on leptons and quarks. It can cause the flavor of a quark to change, causing a neutron to transform into a proton, as in a beta minus decay. Its range is around 10 to the power of negative 17 m. Relative strength is 10 to the power of negative 9. So elementary particles is divided into two, which is leptons and hadrons. So for the leptons, the definition is does not experience the strong force. It is acted on the other three force, but gravitational force is ignored because has a very little mass. It is very small. The next one is hadron. Hadron is a particle which experience the strong force. So for leptons, the structure is fundamental particle because it does not have any internal structure. The lepton family, the structure is the only particle which is not divided into any smaller particle. So the lepton family, the first generation is electron and electron neutrino. The second generation is muon and muon neutrino, and the third generation is tau and tau neutrino, and that is the symbol of the of each of them. So we go to hadrons. Hadrons is divided into baryons and mesons. So for baryons, proton and neutrons are baryons, and baryon is composed of three quarks. For mesons, pions are mesons, and meson is composed of a quark and anti-quark. And that is all from me. I will pass to my friend.
Assalamualaikum. My name is Liati Aina binti Omar. Quarks are fundamental particles, meaning that each of them does not have an internal structure. There are altogether 6 quarks, and each quark has a corresponding antiquark. First, they are acted on by the strong force, and they are the constituent of a hadron. The strong force binds one quark and one antiquark to form a meson, or the strong force binds 3 quarks together to form a baryon. A quark has either 1/3 or 2/3 of the charge of an electron. And lastly, they are confined in the hadron. They are free to move without much force acting on them. But once they try to move further away, very strong forces will pull them back. The table here shows quarks and the charges they carry. As we can see, they all have different charges. For the proton and neutron, protons and neutrons are baryons, hence each of them is composed of 3 quarks. The proton was found to be made up of 2U and 1D, while a neutron has 1U but 2D. Here's some more examples of some baryons and mesons. Next, beta-minus decay and neutrino. Firstly, the nucleic carbon-14 is unstable and it decays by emitting beta-minus particles. It then transforms itself into nitrogen. The kinetic energy has a continuous distribution ranging from a very low value to the maximum value of Tmax. It means that not all beta-minus particles carry the same amount of kinetic energy, some carrying less and some carrying more, although they originated from the same source. The physicist Wolfgang Pauli suggested that another particle was emitted at the same time together with the beta-minus particle during a beta-minus decay. So, the sum of the kinetic energy of the two particles will be Tmax. The nuclear equations for the beta-minus decay by carbon-14 is shown down below. Last subtopic in this video is some properties of the neutrino. The first one is a neutrino is uncharged, so electric force does not act on it. Next, its mass is almost zero, so gravitational force does not act on it too. Number 3 is it is a lepton. It interacts through the weak force. The weak force has a range of 10 to the power negative 17 meter. This means that neutrons interact with nuclear particles only within distances of magnitude 10 to the power of negative 17 meter. Furthermore, since they interact with matter only within very short distances, the chance that they undergo interaction is very slim. Because of all these factors, it is very difficult to detect neutrinos even though a lot of them are available. And lastly, neutrinos are found in cosmic rays and in the core of a nuclear reactor.